Next. So we're going to solve equations using square roots. So solving equations, just think of it as we're getting our x's, or our x by itself on one side of our equation, and we're just going to be having to take the square root. So I set up again kind of instead of steps, like you have to do this, you have to do this. Kind of questions to ask yourself. So if you do get stuck, you know where to go from. So your first question to ask yourself is your variable isolated? Isolated means is it alone on one side of the equal sign. If your variable is isolated, you're good to go and solve. If not, you have to use your opposite operations to isolate it. So that means to like undo, if you have any addition, you have to undo it by subtracting. If you have multiplication, you have to use division to undo that operation. Since we're dealing with quadratics, we're going to have x squared terms. And to undo an x squared, you have to take the square root of both sides. And then in our final answer, we're going to have all square roots today. So we'll always want to check if we don't have a perfect square, if we can simplify our square roots. So, problem number 1a. We're trying to get x squared and x by itself. So we're going to undo operations or solve. So I see this minus 27. I want to move it to the other side. So I have to plus 27 to both sides. That'll leave me with 3x squared is equal to positive 27. All right, I'm trying to get x squared by itself, so I still have this 3 in the front. 3 is being multiplied by x squared, so to undo multiplication, I divide. I divide by the number in front of my variable, so I divide each side by the number 3. That leaves me with x squared is equal to 9. We don't want to know what x squared is, we want to know what just x is. So to undo a square, the opposite operation is taking the square root. So we take the square root of both sides. X squared is equal to the square root of 9. We'll get our answer for x. On our left-hand side, we're just left with x. And then the square root of 9, it's actually positive or negative 3. Which you can write as plus or minus 3. And I'll explain just in a second why it's plus or minus 3. So this is the same thing as x is equal to 3, x is equal to negative 3. You always, when you take the square root of a number that's set equal to x squared, you'll always use that plus or minus. Because if we were trying to get back to 9, we can get back to 9 two ways by multiplying. We could take 3 times 3, that's equal to 9. Or if we take negative 3 times negative 3, that's equal to 9 as well. Same deal if we were to plug 3 or negative 3 back in for x. We'd use 3. 3 squared is 9. 9 times 3 is 27. 27 minus 27 is 0. If we were to plug in negative 3 instead, negative 3 squared is 9. 9 times 3 is 27. 27 minus 27 is 0. So both answers work. So that's why we have to write our answers as plus 3 or minus 3. Right. So there's our first example of the day. Example B. We're trying to get x squared by itself, so I have this minus 10. The opposite of subtracting is adding, so I can add 10 to both sides of my equation to get x squared by itself. X squared is equal to 0. So then to get just 1x, I'll take the square root of both sides. So x is equal to 0. 0 is neither a positive nor a negative number, so we don't have to do that plus or minus. We can just say x is equal to 0 as our final answer. And we could check, we can always check. If we plug in 0 for our original, 0 squared is 0, 0 minus 10 is negative 10. So both sides of our equation are equal to each other. Right, let's keep going. Example C. You always want to work from the outside of your, like far away from your variable, to the inside. So I'm going to always subtract or undo any addition or subtraction first if I can. So I would subtract 11 to begin with. I'd have negative 5x squared is equal to, this would give me a positive 5. And again, if we have a coefficient in front of our x squared term, we have to divide each side by that number. So I'm dividing each side by negative 5. That leaves me with, I would have an x squared is equal to negative 1. If I take the square root of both sides, I would have x is equal to the square root of negative 1. If you were to try to take the square root of a negative number on your calculator or on your phone, you would get an error message. You cannot take the square root of a negative number. Because the only way that we could multiply, there's no way that we can multiply two numbers together, the exact two numbers together, to get negative 1. Because 1 times 1 is 1, negative 1 times negative 1 is also 1. So taking the square root of a negative number leaves us to, on your calculator, it'll say domain error. Do not write domain error. Domain error means that you have no solution. Oop, not for that one. My arrow needs to go up. And you can never take the square root of a negative number. In algebra 2, you'll talk about imaginary numbers, which are just the square roots of negative numbers. All right. Keep moving along. If you have something that looks like this, never distribute and never kind of try to expand. You always want to keep things kind of as small as possible. I described it to my 6th hour as whatever is inside the parentheses here is kind of locked in there until we take the square root. So we're not going to touch anything that's inside the parentheses until we take the square root of both sides. So in the meantime, you have to work to getting the parentheses by itself. So if we have a plus 1 here, I would have to add 1 to both sides. So I would have x minus 2 squared is equal to 25. And now that parenthesis is by itself on the left-hand side. So now at this point, I can take the square root and kind of unlock what's underneath that parenthesis. So I'm going to take the square root of my left side and the square root of my right side. When I do that, on my left side, I'm just left with x minus 2. And on my left side, my right side, I'm just left with 5. Now this is just an equation that you would have solved at you could have done this the first day of the school year. You would add 2 to both sides. So your final answer would be x is equal to 7. You could always check that by plugging 7 back in to your original. 7 minus 2 is 5. 5 squared is 25. Then 25 minus 1 is 24. Thanks. So again, if you ever see a parentheses, add or subtract first to get it by itself. We'll keep going. Example E, I should subtract 8 first. If I subtract 8, then my x squared is by itself. So minus 8 minus 8. I have x squared is equal to excuse me, this would be 11. And then we take the square root of both sides. Square root here, square root here. So on my left-hand side, I have an x, and since I'm just taking the square root of a number, I have this plus or minus square root of 11. Square root of 11 cannot be simplified. All right, so right here, there is no perfect square that goes into 11. So this goes back to what we did on Monday. You can't divide, you can't divide 9 into this, or 4, or 1. 1 you could, but we ignore the 1 case. So we leave it as an exact answer. All right. You could put in square root of 11 and get out a long, long decimal on your calculator, but we don't want that. We just want an exact answer, which would be plus or minus square root of 11. So again, that last step that was in your box up there, you're always going to simplify your square roots. Letter F, again, this is just like a two-step problem. You'd have to add 13 to both sides. So you got 4x squared is equal to 28. Now you have your two steps that are left. Your first step would be to divide each side by 4. So you have x squared is equal to 7. And then, like we would do, take the square root of both sides. Square root, square root. So x is equal to, again, we have to have plus or minus. And there's no perfect square that goes into 7. So this will be plus or minus the square root of 7. And that's your final answer. All right, final two examples. Here we're gonna, again, always do any addition or subtraction first if you can. And subtract 13 from both sides. So we have 3x squared is equal to, this will be negative 21. Divide each side by 3 to get that x squared by itself. So you have x squared is equal to negative 7. If we take the square root of both sides, we're going to be taking the square root of a negative number again. That's always going to give us a no solution. Pretty straightforward. Last one is just like the problem we did before. Our answer is going to look different, but we do all the same steps. We would add 6 and add 6. So we have x minus 3 squared is equal to 27 plus 6 is 33. And now since our parentheses is by itself, or our whatever is being squared is by itself, we can take the square root of both sides. So we would write our answer out as x minus 3 is equal to the square root of 33. X isn't by itself yet, so to get it by itself, we would have to add the 3 over. So x would be equal to the square root of 33 plus 3. This doesn't look like a number right now, but I promise you that it is. Again, this is an exact answer. We're leaving it here for simplicity's sake. Later on in the chapter, when we kind of get to more specific problems, we'll use decimals instead of using our square root symbol. All right, before you jump into your pink sheet, just a few notes on the homework. Square root of 18 you'll get as an answer for one of them. Square root of 18, you have to make sure that you simplify it. I'm not going to tell you how to simplify it, A square root of 18, a perfect square can go into that evenly. So make sure you're simplifying. If you have a number that's in front of your parentheses, x minus 3 squared is equal to 5. Your first step, I'm going to make it equal to 18. Your first step is to divide by 9 on both sides.
Okay.
Never do any distributing. You should not distribute at all in this homework assignment. Your first step is divide by 9. Since we can't add or subtract anything, then we move on to our dividing piece. Our very last one, I don't know why this gives people a lot of troubles, but even if your equal sign is over here, and you have, what is it? I think it's 15 minus 2x squared. If you want to, this is the same problem, just your equal sign is over here. So you're going to do all your same steps. And it's just written differently, so don't let this freak you out. All the other problems, your equal sign is on this side. You have one problem where it's on this side. Nothing changes, it's just written differently.